Here we go. In your note, do 2 circles chapter. We're just going to do a quick review about actually talking about them with you. I hope that you read over them. So our goal today is to focus on 2 keywords. Here's the first keyword, guys. What is it? Here's the second keyword. What's the second keyword? So why did I have you draw 2 circles? Will you quick sketch a tangent in one of those circles? And then quick sketch a chord in the other circle? Just to remind yourself, you've got to be careful about the differences. So I'm going to have this be my tangent example, and this be my chord example. Tangent, interior of a circle or exterior? Exterior only hits how many points? 1. Good luck. I always choose like the bottom or the top. So tangent. Okay, critique my picture. Okay, now the placement. Ah, you got it. What am I missing? Put arrows in there. Tangents is a line, not a segment. Good job, Caleb. Chord, interior or exterior? Interior. Segment or line? Segment, right? So anywhere through, as long as it goes edge to edge. Thumbs up, differences, we remember these? Yeah? Go ahead, Ellie. That's a good one. Okay, so Ellie's question is, what's that word again? If it was this one. Yeah, secant. I don't know why it makes me think of. I swear there's like a sailor term. It's a secant. I'll have to look it up. It's like a measuring tool or something. Oh, that's what I'm thinking of. Good one, good one. Okay, flip it. Next one. Okay, heads up. This chapter, I feel like geometry is pretty straightforward, pretty logical. This section might kind of throw your brain for a loop. Kind of like, what the what? Really? But these are true things, so let's go over them and make sure you understand. Okay, this one right here, I'm going to highlight it. In the picture, which vocab word is this? Yeah, I kind of missed it. Good job. That's the tangent. What's this one? Chord. Okay, that's the chord. So this theorem is saying if you have a tangent of a circle that's touching a chord of a circle, something's going to happen with these angles. Okay, yesterday we talked about a specific kind of angle. Do you remember what kind was yesterday? Right. That came up. Right angles came up. It does start with IN. Inscribed. We talked about inscribed circles. It's the exact same concept. Now this one, inscribed angle, it does not match the definition perfectly, but inscribed angles have to be off the edge of the circle. Do you remember that? Central angles have to be off the center. Ellie, go ahead.
So the tangent is a straight line. What if one is the added together equal 1?
No, not necessarily. Well, it could. We can see. What we're trying to focus on this part though, Ellie, is it's saying to find the measure of angle 1, you cut this arc in half. So if this arc is, I don't know, 80 degrees, that piece of the circle is 80 degrees, because what would angle 1 be? 40. So it's kind of like yesterday's where we cut it in half, but it's not the exact same, because the inscribed angle goes in off the circle right through. Go ahead, Ellie.
Is the angle, like angle 1, is that the angle of the circle and the chord, or the chord and the tangent?
That's a great question. Are you listening over here? Okay, so Allie's question is angle 1 the angle formed by the chord and the tangent, or is it the chord and the circle?
Well, because if one is the size of the curve.
Did you hear Allie's explanation? It's if you use the circle, it'd be curved. It would be an angle. So they're focusing on this piece right here. Great question. Okay, let's do this part. So here's this arc. What if I give you the angle this time? If that angle is I don't know, 120. What's the arc? 240. Okay, I hesitated because I was trying to get a perfect circle, but I don't think I did it. Is that even possible? No. What's the issue? It doesn't have a 3/6, but we're just doing it for an example, right? Okay, so there's the first theorem that you've got to keep under your belt. Okay, let's practice it. Are you ready? So we've got this tangent touching this chord. So something's going to happen with this 4x and this 12x minus 100. Okay, it's like we talked about yesterday and how Caitlin did it on the board. One of them is going to get bigger and bigger. So you have to think through this. If you're nervous, saying the angle is half of the arc. So Oh, I went the wrong way. Half of the arc. So let's set it up. The angle is 4x, which is half of the arc. We're running out of room. It's terrible. Okay, I'm curious. How many of you, this is totally personal with your math skills, how many of you would take that 1/2 and distribute it, push it inside the parentheses? Okay, that would totally work. How many of you would take the 1/2 and get rid of it? Either way will totally work. Okay, so I'm going to show the distributive way this first time. So 1/2 put it there, 1/2 put it there. So we'll have 4x equals, because what's half of 12x? Don't forget the x, so 6x, and then what's half of 100? Is it minus 50 or plus 50 though? It's going to matter, so make sure you have minus 50. Okay, what would you do next in this? Yeah, let's minus it out of there. So minus 6x from both sides. So we'll get 2x, negative 2x equals negative 50. Okay, what's your next step? What are you going to do? Divide by negative 2, and what do you get? 25. Okay. We're just going to write x equals 25 because I'm out of room. Remember yesterday I said be careful of directions in this entire section? Here's a perfect example. Did we do something wrong, Monique?
I'm just wondering, since the arc is twice the size of the angle, wouldn't you just multiply the angle by 2 and then get the same answer?
Yes, you will get the same answer. I'm going to repeat Monique's. This is what we were setting it up as. Depends on what kind of learner you are. So she's saying, can we just double the angle and then set it equal? Absolutely. You'll get the same thing. You can even test it if you want to. Okay, so we got x equals 25. If we go back to the directions though, what are we supposed to find? Good one. Okay, so we've got to go back, take the x and stick it right here. So 4 times 25? 100. So this angle is 100. I have so many colors up here. That angle is 100. What's the arc? Yes, good job. Good job, good job. Okay, any other questions on this one? I'm loving your questions today. Okay, you ready for another one? Can't remember if it's a theorem next. Oh, same setup. Will you try this one on your own? Good luck. Okay, let's go over this one. Monique, I'm going to show your way on this one. So I talk myself through it and I say the angle is half the arc. So the angle, 5x minus 10, is half of the arc. Okay, but what you were saying, Monique, is can we just double the angle first? Absolutely. What you're doing, Monique, is you're getting rid of this 1/2 by timesing this side by 2, but you've got to times this side by 2. Okay, so when you times this side by 2, this cancels out. 2 times a half is just 1. It's gone. But be careful on this side, because you have to multiply everything by 2. So what's 5x times 2? And then what's 10 times 2? Thank you for saying negative 20. You're going to write minus 20. This side you've got 8x plus 32. Curious, how many of you did it this way? How many of you did it the other way, like we did on the first one, the distributive? Either way, we should get the same answer, so let's compare. I'm curious, Kane, what would you do on this part?
Minus, or add 20 to both sides.
Add 20 to both sides? Looks good. Okay, so then we would be left with 10x equals 8x plus 52. Okay, everybody, what would you do next? All at once. Yeah, I thought you'd say the same. Nice. Minus 8x from both sides. Yep, divide by 2. And then be careful, go back and check your directions. So we'll get x equals what? Okay, go back. Do we want x or do we want an angle? Which one? Right here? Do it. Grab your calculators. 26 times 5 minus 10. So eager. 120. So if this angle right here is 120, what's this arc? Good work. Add it in. It's good practice. Who knows which one will ask for? Okay, vote with your thumbs up, halves, down. How do you feel about this first concept? You okay with it? Okay. Next part. Are you ready? This theorem always makes me, I don't know if hesitate is the right word, but I gotta think my way through it. Okay, you know what? You probably want to copy that down. Copy it down and then let's talk through it. Go ahead. When you look at the picture, Are those chords intersecting inside or outside? Okay, they're inside. Guys, when it's inside, you add. I chant that all the time so I remember. So when they're inside, you add, but what are you adding? If you're looking for angle 1, you add up the arc that it cuts and its vertical angle cuts. So maybe right here in the actual theorem in words, let's box up vertical angle. Where does it say it? Right here. You've got to use its vertical angle too. It gets forgotten. So you add this arc plus this arc. Don't forget to cut it in half though. Out of the arcs, cut it in half, it gives you the angle. Weird, right? But it works every single time. Okay, but this works even if it's not off the center. So these could be separate arcs, right? So this could be, totally making this up, this could be like 20, and this could be 30. So what would angle 1 be? Yeah, add them together, 20 plus 30 is 50. Cut it in half, angle 1 would be 25. Yeah, so this angle 1 would be 25, that one. You keep thinking, okay, I'm going to repeat, these are fantastic questions. They're saying if they're vertical angles, shouldn't the arcs be the same? Yes, girls, but only if it's off the center of the circle. Because the arc could get bigger and bigger if it's closer to one edge than the other. Wait, I think through it. Okay, same thing for angle 2. To find angle 2, you would add this arc and its vertical arc, and then cut it in half. Nice. Okay, I think there's one more thing after this. Okay, interior. When it's interior, you add them. Just keep thinking that. When it's interior, you add them. Don't forget to cut them in half. Exterior, you subtract them. Okay, copy it down and then we'll talk about it. So when it's exterior, you subtract. So to find angle 1, you take the bigger arc minus the smaller arc, cut it in half, and that'll give you angle 1. Let's just put random numbers in here that probably won't make sense if we really figure it out. So if arc B is, I don't know, 180 degrees, and arc AC is 30, add them together, what is it? Okay, but don't forget to cut it in half. So what's 210 in half? So that angle 1 would be 105. Wait.
75.
Gotta subtract because they're exterior, right? So 180 minus 30, you got that, what is it? Cut that in half. There we go, let's feel better about that one, right? Okay. Again, we've made up, right? So maybe that doesn't look like 75, we made up answers. This one, exact same thing. So make sure you do the bigger arc minus the smaller arc. Don't forget to cut it in half, you'll get angle 2 every time. Okay, that looks pretty legit. Okay, last one. Same thing, don't forget. Bigger arc minus smaller arc. That'll give you angle 3. Okay, let's practice these. Are you ready? First practice. Inside or outside?
Inside.
Add or subtract then? Add. Okay. So this one, let's add this arc plus this arc. So 150 plus 136, what is it? 286? But don't forget to what? Yep, don't forget to cut it in half. What'd you get? 143. Yeah. So girls, do you see this one? So this one, this is 143. Yes, that would be 143. One of the arcs is a little bit smaller because it's off at the edge of the circle. They brought that up. They're saying this angle right here, McCall, would also be 143. But the arcs are different. Why are the arcs different? Because one's closer to the edge than the other. If it was off the center, then the arc should be the same. Yep. Okay, let's do another example. Okay, letter A, inside or outside? If it's outside, add or subtract. Okay, so here we go. Right? So the big one is x minus this. Don't forget to cut it in half. Oh man, I'm gonna put a box on this so I have room to show my work. Let's do, hold on. There we go. Okay. So this one. We've got x exterior, so we know we have to subtract. Big one is x. Little one is 64. Go ahead, you're okay. Don't forget, oh, Kelly. Babe, you can't go. I'm so sorry. I'm so sorry. Just take the Kleenex with you. Okay, so sorry. Okay. Alright, so we've got x minus 64. Don't forget to cut it in half. So put a little half on the outside. That's going to equal your angle. You okay with that? Okay, this one, I would probably use the Monique way. Right here, because distributing, you've got 1/2 times x, it's 1/2 x. I mean, you can do it, it'll be fine, but I might get rid of this half first. Yeah, let's just double both sides. So double both sides, so what's 58 doubled? Because you're just getting rid of this part. Gets rid of it all at once, because these are safe inside the parentheses. Okay, so we've got x minus 64 equals, what's 58 doubled? 116. Okay, let's add 64 to both sides. Okay, help me out, what's x? 180? Oh, that was convenient. Oh, go back to your directions. Do we need something besides x? Oh, good. Okay, letter B. Interior or exterior? Add or subtract? Go ahead and try to get a head start. While you're getting a head start, Christian, you have a question?
Yeah, why is it 1/2?
It's the theorem. You always gotta cut it in half. It's a great question. Okay, big. Oh, this one's kind of nice. Did you notice? So big arc minus smaller arc. Don't forget to cut it in half. And that will give you the angle. Okay, 68 minus 24. So we've got half of 44 equals x. Guys, what's half of 44? How many of you got that before I did it on the board? Yes. Good work, good work. Let's do it. You've got those 4 at the bottom next. Number 2, interior or exterior. So add or subtract. I know it sounds ridiculous, but it helps. So right here, add your 2 arcs together, but don't forget to cut them in half. So 91 plus 55. What is it? 146. X equals 173. How many of you got that one? Okay. Will you try number 3? It's a little bit wonky, but I think you can do it. Try number 3. Okay, you added 86 and 106. What'd you get?
192.
Okay, then what?
And then I divided that by 2, and I got 96. And that's the measure of the angle JXM, I guess, and KXL.
Nice. So that's this angle. Good thinking. Okay.
And then the same, yeah. And then, so I added those together, right, with that?
Add the 96s together.
Yeah, and then I divided it by, or I minused it from 360. And I got
I see where you're going. Might be an easier way to do it. Because you're thinking the edge of the circle, 360. What if I shortcut you? Tell me if this makes sense. What if we think of this as a line? Because what does a line measure? 180. Could we consider that a linear pair? X and 96. So what if we just shortcut it, Caitlin, and we just do 180 minus 96? You okay with that logic? So what would that be, guys? How many of you got 84 for this one? Okay, is there only one way to do this? What do you think? Absolutely not. There's lots of ways to do this. So don't be intimidated if you went a different route and got the same answer. That will totally work. Let me see again. How many got 84? Sweet. Good job. Okay, number 4. Number 4. Did anybody figure out? Oh. Okay. So number 4, you're welcome. Sorry I had to wait. So bad. Anybody figure out number 4? Some works for this picture. Ellie, what do you think? Okay. Yes, you can do that, but you have to be careful with that. That works when it's this type of angle cutting it because it's edge to edge, right? So Ellie did 360 minus 110 to get this one. What did you get for that? 250. Okay, keep going. Okay, so 250 minus 110, and you got what, 140? Divided by 2, did you get 70? How many of you got 70 on this one? Yeah?
How do you get that?
Which part, Calvin?
Like all of it.
Okay, you ready? We'll start over. The whole circle is what? So Ellie noticed that this piece is 110. Well, if you know the whole circle is 360, she found this piece by doing 360 minus 110. And then everything else falls into place. Big minus small, cut it in half. Thank you for asking. But I'm glad you brought that up, because using that 360 trick isn't going to work on everyone. For example, number 5. Number 5, if you know that this much is 210, there's a problem with thinking the rest is 360. What are you missing? We don't know this much, so we can't use that same trick on this one, Calvin. Right? Okay. Got it. So 210 minus x. Don't forget to cut it in half. That's going to equal your angle. Again, I like them on equaling. I'm going to double everything. You okay with that? So double the 1/2 210 minus x. That'll get rid of the 1/2. So this will just be 210 minus x. Help me out. What's 72 doubled?
144.
I agree. 144. Okay, this one is like one of those backward equations that always confuses my 8th graders. Not 8th graders in this class, don't mean to tell you. My algebra 8th graders. What would you do with this part? Somebody know? Ellie, what would you do? Okay, let's minus 210. It's more like when they're learning equations. This one is weird. Help me out. What's 144 minus 210? Negative 66, right? Here's what new students to equations confuse. They don't bring down the negative in front of the x, so they think x equals negative 66. It doesn't make any sense. Do you know how to get rid of that negative in algebra term? Yeah. You're dividing by -1 on both sides, and you'll end up with x equals a positive 66. How many of you got that one? All right, good work.